Lesson 4.10, Write Quadratic Functions and Models. Means today we're going backwards. What we've been doing so far is taking our equations and graphing them, or evaluating them, finding zeros. Today we're going to start with the zeros or the graphs and write our equations. Finding equations of lines is pretty straightforward, but curves are a little more tricky. So today we'll learn how to fit a quadratic function to some given points. The vertex form is the easiest. You can use that if you're given the vertex and one other point. This is vertex form. Remember, the vertex is hk. So you can fill in whatever your vertex is for h and k. Take your other point and plug it in for x and y. Now that you filled in everything except for a, you can solve for a. Then you'll write your equation. For example, write the equation of parabola with vertex -2, 1 and point 1, -1. Take your vertex form and fill in the h and the k and the x and the y. So we filled in the h and the k, fill in the x and the y, simplify. 1 plus 2 squared is 9. And solve for a. Subtract 1, divide by 9. So a is -2 over 9. Now we can write our equation. So it's y equals -2 over 9, x plus 2 squared plus 1. Remember, this is h and this is k. If you're given the x-intercepts and one other point, intercept form would be the best way to find your model. Remember, intercept form is this: y equals a, x minus p times x minus q, where the x-intercepts are p and q. After you filled in p and q, fill in your point for x and y and solve for a. Then write your equation. Write the equation of the parabola with the x-intercepts of 1 and 4 and the point at 2, -6. So we fill in our intercept form with our intercepts, the 1 and the 4. Then we take our point and fill it in for x and y. Notice there was x twice. We have 2 x's, so we fill in 2 for the x in both of them. 2 minus 1 is 1, and 2 minus 4 is -2. Multiply it together, and divide, and you get a is 3. So write your equation. Y equals 3, x minus 1, x minus 4, where the 1 and the 4 are the x-intercepts. If you don't have either of those, then you have to use standard form, which can be done with any 3 points. The other 2 methods are the easiest. So if you have the vertex, use the vertex form. Or if you have the x-intercepts, use the intercept form. Only use this if there's no other way. So you take each point and you fill in the x and the y of our standard form of quadratic equations. And since you're doing it with 3 points, you'll end up with 3 equations with 3 variables. Variables will be a, b, and c. And then you get to solve that system of equations using stuff we've learned before, such as substitution, or elimination, or Cramer's rule. Lastly, of course, write the equation. So find the equation of the parabola through these 3 points. I'm going to take my ax squared plus bx plus c equals y, and fill in x and y from each point. So my first point, filled in -2 for x, -1 for y, and simplified it. Take the next point, fill in the 1 for x and the 11 for y, and simplify. Take your next point, fill in the 2 for x and the 27 for y, and simplify it. So now we have our system of 3 equations that we're going to solve. And I think I'm going to solve it by elimination. But you could use substitution and you could use Cramer's rule. If I take the first 2 equations, I'm going to multiply the second one by -1 and eliminate c. So the first equation and the second equation was multiplied by a -1. Add them together. Notice the c's are eliminated. Oh, look, they're also all divisible by 3. So I can make it simpler by dividing everything by 3. Then I'm going to take the last 2 equations, and I'm going to multiply the second equation by a -1 so I can eliminate c again. So my second equation here is multiplied by -1, and then the third equation is down there. Add these together, and now we have 2, there's one, the other one, equations that we can then combine. Conveniently, it looks like if I just add these together, the b will be eliminated. 4y equals 12, so 4a equals 12, so a is 3. Now I can take one of those 2 shorter equations and find b. Replace the a with the 3, and so you get b is 7. Take one of our original equations and fill in the a and the b, and you find out that c is 1. So now we can write our final answer. Y equals ax squared plus bx plus c, so y equals 3x squared plus 7x plus 1. Now, computers and calculators can now often find the best fitting quadratic regression. So if you happen to have a TI graphing calculator, you can use the following to find the best fitting quadratic model for a given set of at least 3 data points. On your homework, unless it says use a graphing calculator, you still have to do it by hand and you still have to show all the work. So push the Stat button, it's kind of in the top center. Select Edit from your menu. Put the x values in list 1 and the y values in list 2. Push the Stat button again. Go over to Calc and select Quadratic Regression. Then, depending on your calculator, you just hit Enter again, or you go down and you select Calculate. It should give you the best fitting equation. That's all there is today. You are now done with the notes for the whole chapter.